Good afternoon. My name is Jason, and I'm the founder of Ageless Partners. Our mission is to reverse human aging in our lifetimes. Today, I'm here with Professor John Fagan, who is a chief scientist here at the Health Research Institute in Iowa. He's also a professor of molecular biology at the Maharishi International University. How are you doing today, John?
Oh, I'm doing well, and great to be here with you.
Yeah, thanks for having me in your facility here. So just to start us out, could you just tell us what you do here and kind of a little bit about your research?
Yeah. The big question we're trying to understand is the relationship between how we farm, the quality of the resulting food, and the impact of that food on people's health. So this encompasses aging and also encompasses trying to understand how our food is part of that whole process, of that whole thing.
Makes sense. The more I look into food, the more I've seen how problematic it is, especially here in the US. Have you seen a lot of different compounds like in the food that shouldn't necessarily be there or that could be detrimental from health? Because I know there's some research now that is inferring that. I'm curious, are you seeing that on your end? Or?
Yes, we're seeing a lot of things in the food that is not good for us. Some of it is everybody's heard of heavy metals.
Sure.
Okay, there are problems with heavy metals in our food. Especially, I'm concerned about the heavy metals in foods that little kids are eating, because lead and cadmium, but particularly lead, can significantly depress or reduce the potential IQ of these children.
Right.
And it's irreversible. If this happens when they're little, they spend their whole life with that reduced intellectual capacity. And that's a real limitation for people. And so that's just one example. There are all sorts of pesticides and environmental contaminants, things like glyphosate, which is an herbicide that up until now it was considered safe. And it is true, it doesn't kill you outright, but chronic use of glyphosate or exposure to glyphosate is really a large, what would you call it, risk factor for cancer.
Right.
And on like that. So there are all of these things in our food. We've all heard of the forever chemicals, the PFAS,
Yes.
and the microplastics and nanoplastics that are now being discovered in our foods. And they're all big risks, and we need to do something about this.
Huge problem. And I'm sure, when you look at the incentive structure for big food, and they sell all these products, their incentive is to make as much money as possible. And maybe they do some testing, maybe they don't. But I know sometimes tests are not perfect. How do you see, even if a company says that they do testing, and they say they've tested for, say, lead or one of these other heavy metals, the way I understand is that testing is not perfect. So how do you see that in your lab, like the trade-off you have to make from sort of the accuracy you can get depending on the method you're using?
That's really a critical question, because if you look, and let me use pesticides as an example. If you look at typical pesticide tests that are done by the US government, or that are done by commercial labs that offer their services to the food industry, what you find is that they will have limits of detection for the products, for the things that they're testing for, that are very high. Maybe 10 or many of them 50 or 100 or 500 parts per billion. Okay. Now, it so happens that the machines that they're working with are capable of detecting parts per billion, and not the parts per million that they're focusing on oftentimes.
So it's order of magnitude
Order of
different.
magnitude
Wow.
difference. So we have taken the challenge with this, and we set up pesticide testing that is capable of detecting very low levels compared to what these other labs do. And you have to go to those levels in order to be sure that the food is safe.
I see. So if I was testing something that says like, okay, it has to be below 1 million or 900,000 of these units,
Mhm.
and our measurement tool can only detect like something much smaller. Is that kind of the way to understand it, or?
What it is that the machine is capable of detecting way down here.
Right.
But the food industry people know that the levels that are actually in the foods are up here.
I see.
Okay. And the government knows it's up here. And so when they test, they set a limit of the reporting limit here below the level that they're detecting. But they set it, let me put it this way, they set it at levels above what there is actually that's present.
Okay, so there'd be a certain amount of, call it some kind of compound, maybe it's lead, in there, and they're saying, okay, the level for safety that we can now produce this product is this high, whatever it is, and then they do the test, they say, okay, well, it's below that level, so we can now produce this product or food.
Exactly.
Okay, but how do we know that those levels are not safe, and how are you tying in kind of the instrumentation or the measurement to that?
Well, that's the problem, is that safety thresholds that are set by governments tend to be, or they are set by people who are very sensitive to feedback from the food industry and the chemical industry.
Right.
And therefore, they seem to be more, what's the right word? They seem to be flexible in the way they evaluate safety.
Sure.
So let me give you an example. The US government, EPA, says that it's safe for an adult human being to consume about 2 milligrams of glyphosate every day. Glyphosate is an herbicide, okay? 2 milligrams. Now, the European Food Safety Agency says that half of a milligram is safe.
Right.
4 times lower, basically.
Right.
Okay. Now, if you ask California what's safe, they say actually you have to go down another 1,000-fold, and then it's safe.
Mm.
But then you ask okay, Mr. California, what does that mean in terms of people getting cancer? They say, well, it means that the cancer incidence, if you're eating food that is at this level that we call safe, then the likelihood of cancer is only 1 in 100,000. Okay?
Gotcha.
So now what does that mean in terms of California? California has a 39 million population. And so what the California government is saying is that it's okay for 390 people to get cancer from glyphosate.
From the whole state, you're saying?
From the whole state.
Okay.
Now, or if you look at the country as a whole, 300 maybe it's almost 400 billion now. It's much, you're looking at 3,000 people that could have cancer.
Right.
I don't consider that safe. And if you recognize that that's set on what would be safe for or would be the risk level for an adult, a healthy adult, it ignores the impact of these same chemicals on vulnerable populations, older people, or people who have, whose immune system is not as strong as it should be.
Right.
all of these sorts of things. And so it's really it should be even 100-fold lower than that to be able to say this is a safe product.
Right. Right.
So you can see that this is all the regulatory rigmarole around establishing safety.
Right. I mean,
And-
big food wants to make their money.
Yeah.
And I mean, based on those numbers, I mean, it could be, I mean, the whole U.S. could be getting quite a bit of, at least it could be contributing towards cancer potentially. And I know there's some evidence behind that, like you're alluding to.
Mhm.
But it's interesting that you're talking about, like, well, thinking about that vulnerable population, say like even 80 years old and above,
Mhm.
you know, I wonder what the incidence of contribution to cancer from something like glyphosate to those people, and maybe they've studied it, maybe not, right?
Yeah, and a lot of it hasn't been studied.
Right.
It's when you consider that there are 30,000 chemicals that have been approved by our federal government, and maybe not even 10% of them have been examined in depth for safety. And they're out there, assuming that essentially we're the guinea pigs for these.
Right.
That's not a good way to do. When we talk about living, what's the old saying? Better living through chemistry. Maybe more profitable living for the chemical industry, but
Right.
not necessarily better living.
Right. No, it's pretty bad out there. I mean, the food supply, it's I always think of it's been corrupted, and you know, it's one reason why I don't eat grains. So I pretty much minimize and avoid grains because you don't know if they have glyphosate in them, because
Yeah.
they probably do, right?
Right.
And everyone has their own risk tolerance. A lot of people, they don't realize, like, hey, like these things are in the food, and you can test them and determine that they are there, and it's not like.
Fortunately, there are ways of purifying the system to get rid of these things. And one of the things that we've done is we've looked at a traditional medical system called Ayurveda. And there are procedures in Ayurveda for purifying the physiology. And we actually looked at the ability of this system to remove pesticides from the system. And what we discovered is that, well, first of all, organochlorine pesticides have a half-life in your physiology of between 10 and 15 years. In other words, if you eat so much today, it's going to take 15 years for half of that chemical to be out of your system.
Right.
And another 15 years for you to be down to a quarter, unlike that.
Right.
What we found
That's a long time.
It is. It's
Yeah.
a very long time.
It's a long time.
What we found is that panchakarma, this procedure that's used in Ayurveda for purifying the physiology, a 2-week program of purification is enough to reduce the levels of these pesticides by 50%.
In the body.
In the body.
And that's tested through hair or urine or combination?
That was done looking at the blood.
The blood? Okay.
Yeah.
Okay.
Which is a good indicator of what's going on in the system.
Gotcha.
So this is just an example. There are Western approaches as well, but
Interesting.
I'm intrigued by this one that is capable of really cleaning out. There isn't a known procedure for getting rid of the organochlorines or the organofluorines, which are the forever chemicals, which have even longer half-lives. And so we're very interested in studying these purification methods.
It's amazing. And how long has your institute, and how long have you been doing this? And where do you see it going in, say, the next 5-10 years?
Oh, that's a long, it would take a long answer for that. I'll keep it
Just
short.
high level.
Yeah. So we're interested in understanding more about the connection between our diet and our health and the aging process, all of these sorts of things. And there are many approaches that can be taken to look at these things, and we're exploring a number of them at this point. And that's where the Ayurveda thing came in. But
Okay.
so it's all there.
And how do you see the aging process kind of interrelated in the research you do?
The one thing that we do know is that if you are exposed to these toxins in your food, they're going to reduce your ability to respond to different stressors, and therefore that, or I should say, it reduces the ability to respond, and that naturally translates into reduced ability to push off those influences of aging.
Right, reduce resilience.
Yeah,
Makes
and
sense.
so it interferes, that's a beautiful way of putting it, is that it interferes with an individual's resilience.
Gotcha.
And that's what we need to support, is resilience with our immune system, resilience with these other systems that purify the system and keep you healthy. Your liver and your kidneys and all of these things make a big difference in the way that you can function.
These are important organs. Well, thanks for the time. And what's the best way people can reach you if they want to reach out to you?
Mm-hmm. Well, they could get a hold of me through my email account, and that is John, John, dot Fagan, Fagan, at HRI, for Health Research Institute, Labs, HRI Labs, LABS, plural, .com, or not .com, .org.
Okay.
It's a 501c3 nonprofit.
It's a nonprofit. Okay. Awesome. Well, thanks a lot, Professor Fagan. Really appreciate you taking the time today.
Oh, thank you. This has been a lot of fun.
Absolutely. And we'll see your lab soon.
All right. Yeah. Let's do that.
Let's do that.